welcome to Ways Newton's Method Can Fail. So recall that we have in Newton's method, x sub n plus 1 was x sub n minus f of x sub n divided by f prime of x sub n. So just looking at this formula, we can immediately find one glaring issue. So our glaring issue here is this dividing by f prime of x sub n. So note, if f prime of x sub n is equal to 0, we will not find an x sub n plus 1. So we can't find an x sub n plus 1. And that makes sense. If that derivative is equal to 0, the tangent line will be horizontal, and so the tangent line will have no x-intercept. Let me just give me a little more space here. Give myself a little more space. I can speak English. Okay. So if the tangent line, or if f of prime of x sub n equals 0, then the tangent line is horizontal. And so it has no x-intercept. So this is a place where Newton's method will fail. So if I just draw a quick picture. Right? So if I want to approximate this root here, if I happen to start at that relative maximum, I'm not going to get anywhere. Right? I'm just going to have this situation. So if I set x equals 1 at the relative max, then there is no x2 to be found. So this is one way, and it doesn't have to occur at x1, right? We could be working with Newton's method and somewhere in our algorithm land on such an x value, and then we run into a problem. Another issue we can have is we're depending on these lines working their way into our root, right? So we're depending on the x sub n's working their way towards our root, but it's possible for them actually to work their way away from the root. So Newton's method depends on the x sub n's working their way towards the root. So it's possible that they actually will work their way out. It's possible for them to work away from the root. So I'm just going to draw an example of how this can occur. So if we draw a situation like this, Right, so we have one of those essentially vertical points of inflection, right? Then here's my root that I want to approximate. And if I pick, say here as my original x1, and then draw my tangent line, it's going to shoot me out here. And so here's x2. Now I take that point, draw its tangent line. Let's do another color. So this is x2. And then let's draw that tangent line. And now that's going to kick me out here. And so this is our x3. And then if we picked that point and drew its tangent line, that's going to shoot me even further out. And so now we have x4 way out here, right? And so we're getting shot further and further and further away from our point. Right? So in this case, the algorithm is actually sending us away from the root. It's never going to converge. So these are the main places, the main ways that our algorithm can fail. Is that we get sent away from the point, we don't converge on a specific point. There could be a way that it literally just bounces back and forth between 2 points. That can happen as well. So we can have it so it doesn't approach the root, or we could have just a situation where we can't find the next x of n because we have a horizontal tangent line approximation. So Newton's method is not fail-safe. It's possible for it to fail, but it works almost all the time. Right? So in conclusion, Newton's method doesn't always work. But it will work most of the time. So that's Newton's method. It's one of the common ways for calculators and other math programs to approximate roots quickly. And they will usually go out to 7 decimals, 8 decimals, instead of going out to just the 3 that we did in the previous videos.